The next one, me? Okay.
Yeah, smart contracts.
Let's just talk about smart contracts a little bit. So I have notes because I like to work from notes. But a smart contract, okay, yes, okay. So a smart contract is not a legal contract. It's a computer program, and it has some legal attributes. I think the term was coined by Nick Szabo, right?
Yeah.
So to have a legally valid contract here in Canada and in many jurisdictions, it requires certain elements. So offer, acceptance, consideration, meeting of the minds. These are legal terms of art, and they have a specific meaning. Smart contracts can have these elements, and they often do, sometimes, but not all of them, not all of the time. So you can see why the term has sort of stuck. So some technical characteristics of smart contracts. First off, they live on the blockchain, specifically the Ethereum blockchain. There are other incarnations, like I think R3 has their own, and it has a different name, but I'm just going to talk about the smart contracts on the Ethereum blockchain for now. So they are immutable. So once they are deployed, they cannot be changed or corrected. They're always on. So as long as there are nodes active on the network, you can interact with that smart contract. And they run on gas. So gas is sort of a technical aside, but I thought it was worth mentioning. It costs money to run certain computations on the blockchain. And when developers are writing smart contracts, they have to factor in a certain amount of ether in order to deploy that smart contract. And that amount is called gas. And it's a totally arbitrary term, but if your contract runs out of gas, then it sort of stops. And the price of gas fluctuates similar to transaction fees. So there's a separate market, gas price calculation or something. So now I'd like to talk about oracles in the context of blockchain and smart contracts. So what it is it's an agent that goes out into the real world and verifies occurrences, and then submits that information to the blockchain so that it can be used by a smart contract. So smart contracts are computer programs. They're deterministic. They cannot interact with the outside world. Oracles act as data feeds to provide external data that can trigger smart contract executions when certain predefined conditions are met. So those conditions could be something like the temperature of the weather outside, or whether a payment has been successfully processed, or certain price fluctuations. This is an IoT example that we thought would be useful. So here, the fob swiping the keypad it's an external data input. The keypad acts as the oracle, which sends that information to a smart contract, and when that happens, the smart contract triggers an event. In this case, all of the light bulbs in the house have their own address, so they all turn on. So that's how that would work. And the keypad is the oracle. So it could be a machine, it could be a person, could be any sort of, the purpose is to provide external data in a secure and trusted manner. Now I'm just going to go through some use cases. So some of them are just prototypes, and others are up and running, and you can interact with them right now. So first off, land titles, because lots of people think blockchain and land titles is kind of a popular thing. So a land registry system, like we have in Ontario, we have something called TerraView. It can be so easily transferred over to a blockchain, and this would allow you to transfer land titles via smart contract. It's something that would be probably the most beneficial in in places where there's a lot of corruption or where people don't trust the government. But it's important to remember that in order for a land title system or land registry system to be legally valid, it must be recognized in law by that particular jurisdiction. So you can't just build a technological solution and hope that it will somehow sort of like completely change the land title system and redistribute wealth, you know. So something to keep in mind. CryptoKitties. I think Edwin mentioned it already. It's a smart contract that creates a virtual collectible cat that you can sell and trade. And in the British Columbia securities regulator sort of ruled that CryptoKitties are not a security. They are a new asset class called crypto collectibles. And that's because there's no expectation that they will increase in value. So in that, obviously some do, which is a little nuts, but in that sense, they're very more similar to Beanie Babies than they are to stocks. Wills and employment contracts. So, like I said, smart contracts can transfer assets upon a specific event, such as death or performance of work. But these types of contracts are outside the traditional legal framework. However, there's some interesting projects happening, like open law by consensus is creating a legal markup language, so that when you draft or when a lawyer drafts a legal contract, those inputs will be put into a smart contract, and it can be deployed on the Ethereum blockchain. And to me, why this is kind of interesting is because it can sort of change the nature of the employment relationship. So for example, instead of being paid every 2 weeks, you could be paid by the minute as you're working. So, and that money could be sent to your bank account. So that's something that's kind of interesting to me. And then lastly, corporations. So smart contracts can create corporate governance structures. In the law world, it would be akin to something like articles of incorporation or something like that. So these are sometimes called DAOs, decentralized autonomous organizations. I don't know if you've heard that term. And they can behave in ways similar to regular corporations. Namely, they can raise money. They raise capital like a regular corporation would. And they do that through ICOs, initial coin offerings. So that's what we were talking about with the token, issuing tokens and all of that sort of stuff. So ICOs are a blockchain version of crowdfunding where anyone in the world can participate. And it's its own topic. We could spend a lecture on it, but I'm not going to go into it too much. But I'm going to use like a legal case study to sort of take apart what can happen when things go wrong. So in 2016, a decentralized autonomous organization called the DAO, which is confusing because it's a DAO called the DAO, what they're trying to do is they wanted to be the first digital decentralized investment fund. And it was one of the very first ICOs. At the time, it raised 11.5 million Ether, which was $90 million. And today it would be $1 billion. A couple of things went wrong. First, the smart contract was not properly audited by Socket, who are the developers. There was a money draining bug that was exploited by a hacker, and then $31 million was under the control of that hacker. So, and now I just want to flesh out some legal issues that this brings up. So in that smart contract, they wrote code is law, but code is not law. Law is law. But what law applies in this situation? So the DAO sort of demonstrates how our notions of jurisdiction are being challenged, especially when there are potential plaintiffs all over the world. So if you've ever been involved in any sort of legal proceeding, you have to file in a specific jurisdiction. So here you have the danger of jurisdiction shopping. So a plaintiff could just file in a jurisdiction that has favorable regulations for whatever reason, even though they don't live there. So that's one danger. And there's some interesting technical solutions to this. So many people are incorporating arbitration clauses into their smart contracts to sort of prevent, to sort of limit this potential. Another thing that the DAO touches on are issues of negligence and liability. Okay, obviously the hacker was a nefarious actor, but like, what was Slocket's responsibility, and were they negligent in not having the contract properly audited? And that being said, they had no way of knowing that it would raise that much money. And then also, what's the responsibility of the investors? This is an extremely speculative thing. There's a legal principle called caveat emptor, which is buyer beware. So did they really expect to get their money back if something went wrong? And then that leads into the notion of damages. So in order to file a claim, you must have suffered a loss. But what loss did they suffer? So cryptocurrency is, in law, is not regarded as money currently. And it's a complicated, that issue has not been settled. It's a complicated legal question, but it is not money right now. So with respect to the victims of the DAO hack, like, how could they have to demonstrate that they've suffered a harm? That would be very difficult to do, because it would be like saying, oh, I lost all my fairy dust. Like, please, you know, that sort of thing. So, but you know, maybe that will change, and I think it will within the next year or so. I think the CRA will come up with something, or the Bank of Canada will make a statement regarding cryptocurrencies. And then lastly, there's brings up this legal issue of appropriate remedies. So in law, you would have like contractual remedies or tort, like if you had an issue with your employer, or contractual remedies, or tort remedies if you were hit by a car or something like that. But you also have something called equitable remedies. And that's what happened in the DAO. So it was resolved using a technical solution called a fork, which basically all the nodes on the network got together and decided to bifurcate the chain. So on one chain, it was the DAO happened, the hacker kept some of the money, and on the other chain, the DAO never happened. History was erased, and those that were victims of the DAO hack were able to get some of the money back. So that now we have two chains, Ethereum Classic and Ethereum. So, the time it was a little controversial because it goes against this principle of immutability, but it was equitable. It was an equitable remedy at the time. So, next slide. Sure, thank you. So I just wanted to use this as an example of how the blockchain is sort of really pushing our notions of jurisdiction and liability and control and ownership, and they're sort of being disrupted by the technology. And regulators around the world don't really know what to make of it. They're having a really hard time. So you have some countries that are outright banning the technology. You have other countries taking more of a wait-and-see approach, like Canada. You have the UK is creating regulatory sandboxes to encourage innovation. It's sort of the Wild West of law. And I think to me, it's important to be mindful of how obviously the role that lawyers play in creating policy, but also in helping to draft or to design technology that is equitable and just, and to build that into the technology. So that's all. If you had any answers to this question or any thoughts.
Well, I think you said something that's very important here, God, these mics. I got it on. It's okay. The crisis is past for the moment. What you said about code is not the law. The law is so important, which is that if this is going to work, it's great to see lawyers and designers and other people, in the room involved with this technology, because if this is going to work, it's not going to be because a bunch of programmers think that they can reinvent the economic system because they know a lot more about it than everybody else, which is the classic piece of programmer hubris. There's that XKCD cartoon that's like, wow, this is a really hard problem, and someone's like, well, I'll solve it with algorithms, and then 1 year later it's like, wow, this is a really hard problem. Yeah, we told you. There's whole fields of study of international law and economics, and otherwise that have spent a lot of time thinking about these issues in specialized language, and I'm glad to see, as I think sort of the space matures, that people get involved who don't have programming backgrounds necessarily, because that's the only way that these are going to get addressed, because in my experience, the programmers aren't going to do it on their own.
Pretty interesting. Like me and Nellie and I were at Austin presenting the first presentation to a room full of lawyers. It's interesting that their questions sorry, yeah, thank you. Yeah, so at York University, it was very interesting that the questions that they asked were very, very interesting. They're very technical based. Basically, who's in charge if this happens, or what happens? A lot of legal technical questions were asked there, and they brought up some problems that we didn't think even existed. And you mentioned how you can make sure CryptoKitties is only one. There's only one. The act of making the network say something else is called forking it. So if the network forked, then you can have multiple CryptoKitties. The thing is, back in the day, that was 2015 when the fork happened. I think it was much easier to do that. The network was much smaller. You didn't need to convince millions of people. Vitalik, the architect of Ethereum, he had a lot of sway with the network back then. To do the same thing now would be much more different. And in some ways, I'm kind of glad it happened in the past and that we went through this. Yeah.
Just sort of to that end, you were talking at the beginning about switching from proof of work to proof of stake. Wouldn't that require a fork of some sort?
Yeah, so like all other software, it can be updated, and yes, it does require a fork into the new kind of system. What Ethereum is proposing to do to kind of lessen the gravitas of this is to switch to a hybrid system first and slowly kind of ease out the miners and switch to the validator system. So at first, and I don't know when they're going to roll this out, but what they're going to do is they're going to have the miners still be there, but then for X amount of blocks, those are going to be determined by the validators. They call them epochs, I think. So for after every 100 blocks, the determinants of one epoch are the proof of stake validators, but the miners will still be there. But yes, that will require forking. Yeah.
Yeah. The intention is not to have so many miners drop off if you just immediately.
I have a thought and a question and sort of an interpretation or some thoughts around the idea of code and law and them being the same or different. And I say this as somebody who knows very little about law, so I would be interested in sort of getting your thoughts on this. And that is, one of the differences that it seems to me as somebody, I'm a software developer, so I'm sort of familiar with that space, but as I said, not with law. One of the important differences, it seems to me, between those two worlds is that in computing, encoding something, information or instructions in the form of algorithms is very brittle and hard to modify, in the sense that to encode something on a computer, we have to encode it as a number ultimately, and we have to decide when we're going to encode something as a number, we have to decide what those numbers are going to mean. So the number of things the vocabulary of things that we can express has to be decided upon whenever you write the encoding that you want to capture that information in. And then if you want to then come back to that in the future, it can be a difficult problem to sort of expand or make something more flexible or change the sizes of vocabulary. So we have a system that can be very brittle and hard to change. It seems to me to have a working legal system, there has to be people involved. So we have laws that we've written, but to have those laws function, we have judges and we have courts and we have people that are looking at the laws and the cases that have come sort of that are related to the laws, and we're applying these things that we've agreed upon in new situations, but we're able to evolve our thinking, and we're able to add to the laws, and we're having human determination and thinking and arguing as we're using these things. There are people involved, whereas something that's encoded so a computer can understand it, there aren't people involved. I mean, there are people that write the software, but there are people that build the computers. But once the machinery is running, the people are out of the system. So there isn't this mechanism by which there are people that are doing the interpreting of what we meant. Does that make sense? And I'm wondering, like, how does that?
Well, I think maybe not so much for blockchain, but I think those questions are being raised by people that work in AI and that its application to the law. I read a paper called "The Future" or the Legal Singularity, and about how that would all play out, and having sort of dueling AI lawyers. I think the truth is, I don't know. There's a tremendous need for access to justice, for affordable legal services for people to access the court. And if technology can help in some way by freeing up some of those resources for other things, then I think that would be great. I think there are certain situations where, like a criminal proceeding, where maybe we don't want to have technology. We don't want to replace that human element, and also the fact that that the courts, over time, they evolve. They look at past precedents, but they obviously look at the sentiment of society and what's happening in the world, and human judges make decisions based on that, and so that's how the law moves over time. And I don't know exactly how we can build that into an AI judge who is just looking at the facts and what was decided here and what was decided there, and sort of coming to a conclusion based on past cases. So,
I want to say that, when you mentioned oracles earlier, well, first of all, I think that there's kind of a utopic kind of view of, like in the old Star Trek trope where they kind of land on this planet and there's this gigantic god that the natives are worshiping. It turns out to be a huge computer that like determines what is law and what isn't. And I think that there will always be a human aspect, like in terms of this. And you mentioned oracles in terms of providing input from the real world into these systems. Well, that could be a thermostat that essentially, when a temperature drops off to a certain point, does something. It can also be a person. It can also be a judge that officiates that contract, or a third party that kind of signs the smart contract with their private key to prove that something happened in the outside world. And as of right now, smart contracts can't actually self-act. They always have to be activated by a person. So the person sort of.
For me, though, I was sort of thinking about we have biases in the real world, in the legal system, and how do we not replicate those biases in the technology? So, you mentioned earlier about how we're just the same worst elements of capitalism are sort of being replicated in the blockchain space, and I don't know. It would be much worse for the legal system if our biases were replicated.
I'm tremendously interested in this topic, which is